Hello, class. Mr. Bean here. Yeah, I'm sorry. The last video was asterisms and using the Big Dipper introduction to the night sky. This video here, along with Ed Puzzle, will allow you to make up the lab number 3 if you missed it last class. So we'll go ahead and start off here and discuss how things start out. Here we have a kind of slide this off to the side here for right now. Kind of go over here. Okay, and here we have the Earth here, and we'll go ahead and kind of rotate the Earth here. Here is where we have what's called the prime meridian. Let me go ahead and kind of put it back here. And this is the prime meridian. It goes this way, north and south. And of course, here's the equator. So here's a city here called Greenwich, England. So whenever I refer to prime meridian, we'll also want to know that it does go through Greenwich, England, or it goes through England. And this is also uh, what we call the where the day starts. Like universal time is based on this line right here or this location here, universal time. And I can go over here and I can move this. This is us right here. So right now, let's go ahead and pretend that we're at the prime meridian. Almost right. Yeah, close enough. So the prime meridian, if we're here in Greenwich, England, we would go up 51 degrees north up here, and the equator on the prime meridian, we're about zero point 0.1 degree west of the equator. So right now for this exercise, what we're going to discuss now, we are in England. Okay. Now, an important thing to know about that is let's compare the sidereal time with solar time. So, in about right now, it is September 14th. Okay. And let me go ahead and kind of pull this up over here. And no, we don't want that. Let me go ahead and find A3 here. Let's go with right here, A3, and let's go ahead and borrow this one here and take a look at it. And so September 22nd is going to what's called the autumn equinox. That's going to occur, in about 8 days. So let's go ahead and take a look here and see what happens. Let's go ahead and go to autumn equinox. There it is. So here's the autumn equinox. So in London, remember now we're in London, we're in Greenwich, England. The solar time. So this is a 24-hour clock. The solar time at that time is 12 a.m. and the sidereal time is also 12 a.m. or 0. Okay, they're both the same. Okay, so on this day, solar and sidereal time are the same. So let's also figure out what happens on the September 20th. If you look here, September 20th, the sun will rise due east on September 20th, and it'll also set due west on this day. Okay, all right. So let's go back to here. Now let's go to what's called the winter solstice. This occurs in December. So let's take a quick look at that and let's see when the next major event is. Looks like 12/21/20 is going to be the winter solstice. So let's take a look at that and we'll go winter solstice. It's moving around here. Now let's compare solar time with sidereal time. So solar time, it is 6 a.m. in England, and the sidereal time is now 12 p.m. So we seem to have a 6-hour difference. And let's go over here and figure out what happens on December 21st. Let's hit play. Okay. Well, okay, let's go back again. Let's go ahead and try to stop it on September 21st. And let's see how close we can get. I haven't played Xbox in a while, so let's okay, so September 21st is going to rise almost southeast. Okay, and this will be the shortest day of the year. Shortest day of the year. Now, the next major event, take a look here, is going to be 3/20/2021 is called the vernal or spring equinox. So let's take a look at that right here, the spring or vernal equinox. Now, if we look here, solar time in England is 12 p.m. The sidereal time is now, um, what we have here is uh, looks like 12 a.m. So there's a 12-hour difference here, okay, on the vernal equinox. This is going to occur about, was it March 20th? So let's go back to, actually, it's going to occur March 20th. Let's go back here to this and let's see the vernal equinox. We're here. And let's go back all the way over here. Let's go. And let's go ahead and try to stop it right here. You'll see that's going to be September. And let's go to about March. Boom. Okay, well, March 27th. So March 20th would be over here, and the sun will rise due east. Due east. Okay. So after the vernal equinox, we have the summer solstice, which will occur 6/20/2021, the summer solstice. So let's go take a look at see what happens here. We'll go ahead and hit uh, summer solstice right here. And now here, the solar time is 6 p.m. or 1800 hours. The sidereal time is 12 p.m. So whether it's 6 p.m. or you use 1800, the difference in time is 6 hours. 6 hours. Okay, and this will be the summer solstice. So let's take a quick look here and see what happens on the summer solstice here. And let's go and hit play, and let's see, let's stop it. Boom. Okay, well, we're close. So it's going to be rising. So on June 20th, it's going to rise about the northeast. This will be the longest day of the year in the northern hemisphere. Okay. And then finally, we're back to the autumn equinox here. And so on this day, the autumn equinox, solar time and sidereal time will be exactly the same. Now, here's a interesting question here. The next day, how far apart will these be on the next day? Okay, something to think about. All right, this will conclude part one of the lab here. Go ahead and hit stop.